So I really want to hand this over to Luis, get it started where he can uh, talk about all these solutions for us being able to create resilient web applications. And before that, I just wanted to call out that this is, I think, the first virtual user group that we are doing with all the Florida user groups. So some of us are from Orlando, some of us are from Jacksonville, Miami, Tampa. So we all got to be together and be, part of the Florida AWS community, and that's really exciting. So thank you all for joining, and then for anybody who's going to be watching the recording, thank you for watching the recording as well. Luis, to you.
Okay, so thank you for that. Hopefully my camera is gonna be coming up very soon. There you go, my camera is already on. Hello everybody, my name is Luis Guirigay. I'm the worldwide leader for AWS Solutions for Core Services in Advanced Compute. With me, I have Daniel and Basim. Daniel, you wanna do a quick intro?
Sure. Nice to meet everybody. My name is Daniel Zilberman. I am also part of Technical Solutions team, working very closely with Louis on with our customers on identifying their use cases and building solution and guidances to help them solve these use cases.
Thank you. Basim?
Hello everyone. My name is Basim Wanis. I am a software developer engineer that supports that specific solution that we are presenting today. And I help with the support and building new features for AWS solutions.
Thank you, Basim. So, by the way, I'm physically located in South Florida. I'm about 20 minutes west of Miami. Daniel is in San Francisco, and Basim is in Canada. So, thank you guys for joining. So, guys, as John mentioned, one thing I'm working on right now in my role of leading AWS solutions globally is to connect with AWS user groups all over the place. In my previous roles, I used to work for IBM for many years and then for another company called HCL Technologies. I find huge value in user groups, right? It's organized, it's driven, is supported by the community, by business partners, by customers, and I always found talking and working with user groups one of the most valuable engagements in my career. And the reason why I'm doing this with user groups is because I did talk to a couple. I talked to Jeff as part of the Florida user groups, or specifically Miami. I did talk to a couple of user groups in like UK, France, and other places in the US. And one thing I found that it's very common is that very few people know about AWS solutions in our portfolio. So what I wanted to do today is walk you through who we are, what we do, and probably opening the door to what we think is one of the best solutions for someone that is either a developer, a builder, or a just a system administrator. As I said, I lead the team globally from the business and technology point of view. Daniel is one of our senior solutions architects, and Basim is a software development engineer. So with that, let me see, there you go, perfect. So we're gonna talk about who we are, what we do, and then we're gonna go through, I'm gonna just do like a little, almost like an appetizer into another solution that is very popular. I'm not gonna spend any time, or I'm not gonna spend too much time on that one. And then we're gonna focus on distributed load testing, which is actually the solution that helps organizations worldwide to build resilient web applications. Then Q&A, next steps, and so on. Now, let me tell you who we are. We are an organization within AWS where we build products, right? We build two types of products. We build something called guidance that many of you AWS builders are familiar with. Guidance are you know, pieces of code, sample code, reference architecture that basically help you solve a particular problem, right? And guidance are, open source. They are available in the solutions library, and you can find guidance for many, many, many use cases in many, many domains. Everything we build, by the way, goes in the AWS Solutions Library. This is where everything goes. You can see the link right there, aws.amazon.com/solutions. So we talk about one of the type of products we build, which is guidance. The second type of product we build, and this is why somebody like Basim, you heard the word software development engineer, is with us, is because we also build, think about it this way, commercial products. AWS solutions are officially supported products from AWS. In many instances, in many cases, there might be particular use cases or challenges that no given AWS service can solve on its own, or you will have to combine not only multiple AWS services, but also open source projects and custom code and a bunch of other things to actually create a solution out of it. So that's why, within the AWS solutions organization, not only we have, solution architects and, and account managers and support engineers that in their own time, they contribute to building many of our solutions, but we actually have a proper software development engineering organization building these officially supported products. The rest of this session, I'm going to focus on that. I'm going to focus on the officially supported products. Again, products that you guys can go and deploy and basically start using within 5 to 10 minutes. And Daniel is going to give you a really cool demo on how you can start leveraging one of our solutions. In total, we have, as of today, July 25th, we have 61 AWS solutions in market. We have more than 400 AWS guidance as well available, as well as many partner solutions and and other type of content and services that can help solving all of these use cases. But if there is one call to action I would like to ask everybody after this call is, if you have not been there, go to the solutions library, explore what's available. There are solutions for networking, for databases, for Gen AI, for machine learning, for security, and so on, right? We also have solutions for specific industries. As you can see, we're using a financial service industry Zoom account today. So based on the industry you are, just go to the solutions library, and I'm pretty sure you will find quite a few interesting solutions or guidance. So now moving on to AWS solutions. Everything we build is 100% open source. That's very important because, when we build these solutions, we want to make sure that you are confident that what you're using, what it's deployed, you can completely scan it, look into it, no strings attached. You can even go and modify the code if you want to. There might be a solution that, hey, this is great, but it doesn't 100% fit my use case. So you are more than welcome to make use cases to that particular solution. And guess what? Even after making some changes to the code, we can still, best case effort though, we can still do our best to support that particular product. The other attribute is that AWS solutions are single tenant. That's one of the biggest differences between AWS services like VPC or EKS or EC2 and AWS solutions. AWS services are deployed and managed by AWS as an organization. It's basically a SaaS model. But AWS solutions are single tenant. When you find AWS solution, a solution that you want to deploy, you want to use, you go into the solutions console and you deploy that solution within your account. We have many solutions that are cross-account, cross-region, and so on. But what's very important here is that you are the owner of that solution within your account. You deploy it, you manage it, and if you need support, you can go ahead and either open a case on GitHub, or you can, through the AWS channels, you can request a support case with AWS. I said this before, but I have to keep saying that, is fully supported by AWS. These are commercial products fully supported by AWS support. And last but not least, pay for what you use. This is the traditional AWS service model. These solutions, these products do not have license fees. You deploy, you use it, you uninstall it, you don't pay anymore for it. And also based on the type of solution, the cost model might be different. Some solutions, like for example, the one where we will spend the majority of our time today, DLT, distributed load testing, is heavy on using ECS and Fargate, where other solutions are heavier on using EKS or maybe databases or Bedrock and so on. So based on the solution, the cost model is different. And one thing that maybe, Daniel, I can ask you as you start doing your demo, maybe we can go to the DLT documentation page where you will see that every single solution we have in our portfolio, one of the links you will see in the documentation is the cost model. So you have a really good idea of how much this solution is going to cost as you use it. Now, let's start with the first solution, serverless image handler. This is a solution that it is ideal for any organization that has any type of online digital presence, whether it's through web applications or even mobile applications. And what serverless image handler does is, actually it does multiple things, but I'm going to highlight two. Number one is, if you are an organization where you have to, let's say you have 100,000 images because you have like an online catalog, or you have some type of, a catalog where you have to, manipulate or present or deliver, multiple images, most likely all these images have to be also delivered to 100 different type of devices. So one of the things that this solution does is in real time, it lets you manipulate those images rather than having one particular image that you have to save, 10 different copies in 10 different sizes. With this solution in real time, you can actually resize the image based on the device that it's going to be using that particular image. And another thing that it does that is actually pretty cool is content moderation. If you have a website or application where you actually let your customers, your users, to upload images into your site or portal, you can use serverless image handler to make sure that those images are not violating, are not breaking kind of those compliance requirements, whether it's violence, sex, nudity, things like that, or maybe even a person in the picture. If you think about, like, for example, real estate, if you have a website where you want people to upload pictures of like houses and places and apartments, you can make sure with serverless image handler that there is actually no people, no pets, nothing other than the piece of real estate on that picture. So again, this is a solution that gives you all of that. You don't have to build anything. The solution is ready. You can go ahead, deploy it, consume it, and I don't know, let's say within 10, 15 minutes, you deploy the CloudFormation template, and now the solution will be ready for you to be used. Ideal for e-commerce, ideal for companies that have media or any type of kind of images heavy content management websites, and also for mobile applications. We're going to send the link, or we're going to send the PDF after this event. We're going to send the PDF to everybody, so you will be able to access all these links. We will also be sending a one-pager PDF with some like summarized data of some of our most recommended solutions. But right here, this is one that you would like to for sure know about. I talk about content moderation. I talk about cropping. The other thing I didn't mention is storage, right? One of the things that this particular solution uses, in addition to open source libraries and custom code to do all the manipulation, resizing, and cropping of the images, we also use CloudFront for efficient storage and delivery. So you will be saving a lot of space and storage and consumption of S3 by having all these images resized, but also being stored in CloudFront or your content delivery mechanism. This is a very simple reference architecture of what the solution is in terms of technology or services behind. I'm not going to go through these. There is more than enough documentation about this. But one of the things that this solution gives you is a really quick, like a simple to use web interface, so you can actually play with the images and have a better understanding of how these images will react to the different changes you want to make. And This is just a subset of all the different functionality. Again, if you look at the documentation, you will see that it's actually even more powerful than this. Now, let's get into DLT. Serverless image handler is one of the many solutions we have. As I mentioned before, DLT is this like very appealing solution that even if the application you want to perform, you want to do a performance test on it, even if that application is not running on AWS, you can still use distributed load testing. So the name of the solution is distributed load testing on AWS. Is a solution that is available in our AWS solutions library, and it helps you perform or run performance testing on your environment, whether it's an application, a mobile app, or your entire infrastructure. Now, one thing I like to do before actually talking about the solution is talking about performance testing in general. Most people believe, or a lot of people assume, that performance testing is just how fast my application is, right? Oh, I need to do performance testing. I need to see how fast the application is. But in reality, performance testing is way more than that. Performance testing is actually 5 different type of tests that you need to make or you need to perform on your application to understand the different behaviors based on the condition. And let me go one by one, left to right. Load testing. Load testing is, let's pick a random scenario here. Let's say that I have an application for, I don't know, soccer games. You know, we are all in Florida. There was a lot of soccer very recently, both in the US, but also in Europe. So let's pick soccer. So let's say I have a team, right? I have a soccer team, and I want to understand how my website for my soccer team behave under expected workloads. That is load testing. I'm assuming, or based on historical data, I think my website will always receive between 5 to 10,000 users during any given time during the day. Okay, perfect. So I can create a test to simulate, and this is what one of the things that distributed load testing does. It gives you all the simulated workloads, so you don't have to worry about calling your friends or calling a bunch of people or trying to come up with ideas how do I do all this simulation. No, DLT actually give you all of that. So let's say that, okay, I have my website. I want to see how my site performs under regular load. I go into DLT, and again, Daniel is going to give you a demo of all of that. And I'm going to say, okay, I'm going to simulate 5,000 users for 5 minutes. Perfect. That's it. You run the test, and distributed load testing is going to create the 5,000 users, the simulation of what those 5,000 users are supposed to do. And then you will go deeper into how you can create scripts and REST APIs, or based on the functionality you want to test. There are different ways to control that. But the idea is that DLT will give you that load simulation for 5,000 users. And at that point, you will not only see how your application reacts to it, but also how the metrics, or how the performance itself, how like my application is responding, latency, and things like that. So that's the first type of test you can do. The second one is stress. Black Friday, a very common use case here in the US, right? My site under regular load, it's 5,000 users. But what happened on Black Friday if I'm now selling shoes, 50% cheaper? It's going to be under stress because everybody's going to try to hit that website to get those shoes. With DLT, you can also do that, right? You can go from, okay, now I want to simulate, instead of 5,000 users, I want to simulate 1 million users. I want to simulate 2 million users or 500,000 users. You can do all of that. And load, traditional expected load. Stress is like those special cases where things are going to go from like 5 or 10,000 to maybe 500,000 or maybe to 1 million. So that's another type of test that you want to do, because once again, If you have, for example, like an EKS, based solution, you would like to see how fast your application and your EKS cluster is going to spin up new containers to handle the workload. That's one of the things you would like to understand, or you need to understand when you do stress testing. The next one is endurance testing. And endurance, what it is how does my application, how does my solution, or how does my environment behave, under this particular scenario, whether it's 5,000 or a million, for a period of time, right? Endurance. So yes, I can scale to a million. My environment scale up. It kind of brought up all these new containers. Okay, perfect. But what happens if I stay in that 1 million for 5 minutes, 10 minutes, 1 hour, 6 hours? What happens? And again, that applies not only to stress scenarios, but to regular load scenarios. So that's what endurance testing is. The next one is a spike. A spike is for you to simulate these situations where your visitors or your users go from 5,000, 20,000, a million, and then suddenly come down to 50,000 and then go up and down, up and down. The idea of doing this type of test, and I keep going back to my Kubernetes EKS example because of the scalability, behavior of Kubernetes, the outscale behavior of Kubernetes, is that I want to make sure that if my environment suddenly goes from 10,000 users to a million users, I want to make sure that Kubernetes scale up to support that workload. But as my users come down, let's say back to 10,000, I also want to make sure that my EKS cluster also scale down, because now I don't need that much power anymore. So that's why that particular test is very important to see how your application behave when it goes up, but also when it comes down. And the last one is scalability. This is another important one because especially during situations like Black Friday, you want to evaluate how it goes from 5 to 10 to 15 to 20 to 500 to a million. This is another way for you to understand the 5 different types of behavior that can affect your environment, all the way from what you know as to be an expected load, to under stress, to a completely unknown scenario, which is a combination of endurance and spike, where we just don't know, right? So that's why you have to run all these tests to make sure that your application, and emphasis on this word, is going to be resilient, right? It's going to be resilient to whatever workload is hitting that particular environment or that particular application. Now, that's where DLT comes in help. And I hope you appreciate the little, analogy here. That little guy holding the elephant, that's you. That's your application. That's your system, right? You need to understand how your system's going to be able to control that. DLT is a solution that not only is going to help you understand how your application behave, how it performs, but it's going to give you all the tools. And again, it's powered by ECS and Fargate to do all the simulation at a minimum cost, right? And this is the link to the solution. You will be able to download it, play with it, and it's going to take no more than, I think, 10 to 15 minutes to actually get this up and running. This is my last slide. I'm actually going to let Daniel to go and start showing the demo, but here are a couple of things we're looking at doing with DLT. Remember, DLT is a product. It's not a sample code. It's not like something that somebody in their spare time developed and now we want to promote all over the place. Now we actually have product management, we have engineers, we have solution architects, we have people behind this particular solution, and because of that, we also have multi-year roadmaps. Right now, one of the things that we're looking at doing for the next release, which is release 4, is a support for Gatling, which is another type of framework to do performance testing. Today we support JMeter. We're introducing K6, but we're also planning on introducing Gatling support. Another thing we're looking at is IoT device simulation. So DLT, distributed load testing today, not only supports simulating users in the ways of REST API or gRPC calls and a bunch of other mechanisms, but we're also looking at, are you in an industry where you would like to simulate, I don't know, 100,000 refrigerators, right? Calling the store and ordering milk, maybe, I don't know. But it's one of the use cases that we're hearing that IoT companies that provide any type of IoT devices or services, they would like support that. The other thing we're looking at is DDoS attack simulation. That's another very important use case. This one is a bit more complicated because we AWS, we don't produce DDoS attacks, but we're looking for a way to, for organizations to have a safe, reliable environment where they can, again, understand how their organization could behave under a DDoS attack. These are not committed. These are ideas. These are candidates. But I would invite everybody to, when you go to the solution page or to the GitHub, register, subscribe, bookmark that particular solution so you can be notified when all these updates and other updates come along with the solution. And with that, I'm going to stop sharing. I'm going to let you, Daniel, take over the screen, and I'm going to look in the chat to see if there's any question I can help with.
Thank you, Luis. I've placed some links there preliminary for the solution landing page and a couple of what you mentioned for the cost, because I'm not able to see the chat while I'm presenting. So maybe you guys, you and Basim, can monitor the chat window. That would be great. And with that, let me see. Do you see my screen?
Yes.
Yes, we see your screen.
Okay, great. So this is the solution landing page. As you can see, this is part of our solution library, which is a pretty simple URL, aws.amazon.com/solutions. This is already zoomed in to the architectural diagram because that's where we typically start. As architects, I'm not going to go through each and every step of this. You can definitely go over them at your free time. Let me just do the high-level overview of how this solution is structured. So we have the front end that deals with the presentation layer, which, as you can see, is rendered through our CloudFront distribution, and it's hosted through this Amplify service that is basically website content hosting through on S3 as a backend, right? And then we have an API that handles interactions between the front end and the back end and further down, right? So we have API gateway, which controls basically all the interactions. It fronts the calls and then it interacts with microservices, which are running as our serverless Lambda. Lambda is a very popular serverless code execution engine that is used throughout this solution. In this case, it does some basic coordination of authentication and authorization through Cognito, and also role mapping through the identity and access management, IAM in short. So basically, this is a front-end layer that's responsible for serving the content, serving the UI, and handling authentication and authorization. So then we have a backend, which is sort of a central control plane that handles the overall test coordination, right? As you can see, they have actually it's the step functions, which is in the Lambda family, that coordinates the orchestration of running tasks, right? So it's task runner functionality that is responsible for coordinating of task execution. And the data is that it receives back from the execution, which we're going to talk about in a second, is persisted in our NoSQL DB, which is DynamoDB, highly performant serverless database. that can also be highly available, as well as our simple storage service as free that persists, logs and test scenarios and other relevant information, right? So this is a backend. This is also control plane of the solution. And so now, before we move into this part, which is the regional part, so that can be more than one of this, right? I want to make a step back and talk about how do we achieve scale, right, in this solution. And the answer is using containers, right? I'm pretty sure that everybody on this call is familiar with container concept and perhaps work with them in some capacity. So we can easily achieve scale by, scaling containers, right, that simulate individual user or users connecting to a website, right? Because they're self-contained, they can be easily scaled declaratively, right? We can tell the underlying application platform, in this case, it happens to be ECS, Elastic Container Service, to deploy X number of such containers. Each of them will perform a test task. And notice that the underlying infrastructure for that's, containers have to run somewhere, right? It's a Fargate, which is also on-demand serverless infrastructure that basically provisions nodes, right? The instances to run the containers upon based on a specified resource capacity. So the reason I mentioned all that is to sort of, go under the hood and explain how the scale is achieved here, right? Now, container has to come from somewhere, and in this case, it is a container image based on an open source load testing project called Taurus. It resides in a container registry, Elastic Container Registry, and that image is used in tasks. That is the term for the ECS, which is similar to a pod in Kubernetes, to actually run, testing script against the target, and then send the results to our log event monitoring service, CloudWatch. And also, if the live update is selected, in addition to that, another Lambda function will take the event information and send it to IoT Core that will publish it to the topic so the console can subscribe to it and get this information. So with that introduction, let me jump into deployment. And one of the advantages of most of our solutions, you can launch it right into your console, right? So I have to re-log in to mine because it was idle for a little while. And of course, I'm not going to actually run the whole deployment because it takes a little more time than we have, but this is just to illustrate, so you can launch it at pretty much a wizard, and you can specify the name of your stack, right, that will be created. So I'll give it a name. Important thing is we want to give the username for the administrator user, right? That's going to be somebody who is responsible for configuring this solution tool. Sorry. Right? If you want to use your own existing VPC, which is, we don't see it very often, but for some reason you can specify the ID and the ID of VPC, and IDs of subnets where you would like it to be deployed. Or typically these are default values for the internal networking seeders, the address ranges that will be created in the VPC where the Fargate will be deployed, right? So typically, we go with a brand new VPC, we continue. Again, if we have specific role you want to use to run the task, we can create one. Otherwise, we'll let the call formation create a new one for you. And there's some options whether in case of failure, what to do with the already provisioned resources, roll back on or preserve and keep those that were provisioned successfully. So after we go for this, we confirm that all the parameters are as we want, and we click, we acknowledge it, and we click submit, right? I'm not going to do it because it's already been done before. So what we should see as a result, we should see this stack provisioned, right? Ideally, there's not going to be any errors. Everything goes well. And in the outputs of the stack, and by the way, it's all covered in the implementation guide. I previously placed this specific URL there, but if you remove the, this particular page, you will land into the beginning of this guidance. So you can definitely follow it for all the details, steps of implementation, right? But for us, what's important is the console. Remember that console is Cloud for distribution. So we will log in there. Before that, let me quickly show you the users that were generated, right? Because remember, we just specified the admin user, and that is the entry that was created in the user pool in the region that we specified, US East 2. And here is our admin user with email address. Now, initially, the password is auto-generated for you. You get an email on the specified email address. You log in to the endpoint that is specified here in the output, and then you change the password. That's a one-time activity, right? So I've done it already. So I will just log in with the password I specified, and hopefully the gods of demo will be cooperating today, and everything will go well. Okay, so this is this is the landing page, right, of this solution. The interface is pretty simple, but it's definitely functional, right? So here's a dashboard. We are at the dashboard. We see all of our previously defined tests. Again, due to the time constraint, I will basically go for the previously created test, but I will explain the how it will create it, right? So in this particular case, I wanted to test the endpoint, which is actually running some nice little app on the Elastic Kubernetes Storage, EKS. And this is basically like, test app that allows you to vote for some types of food. So if we edit that, and that's the same process as we'll create a brand new test. We give it a name, right? We want to give it description. We can select a region, and by default there is one region where the solution was deployed. Since I have also added multiple regions, because remember there can be more than one, so there can be distribution of our testing engine, so to speak, across the regions. But we'll cover it in a few minutes, right? So we select this region. The important parameters are task count and concurrency, right? So task count is basically number of containers that will be launched in the cluster to run the test scenarios. So this is important because this is, simulation of, somebody running a program on their computer that hits this endpoint, right? And the second important parameter is concurrency. Concurrency is how many virtual users generated per task. There's a certain limit that is recommended. and that's based on a CPU and memory that's available to run these containers on that backend, this dynamic Fargate backend for container service, right? So I deliberately put very small values there because we're not really loading that endpoint. Now you can always see how many tasks you have available. That's kind of your pool that you can work with. So you see we have 2,000 tasks available. So definitely we are well below that limit. So I'll increase it. And also two parameters that are also important is sort of the warm-up time. So we will give the testing system some time to reach the target concurrency that we specify here, right? And that's basically 5 multiplied by 3, 15 total user tasks, right? So we sort of guarantee that for a minute, the system will reach the target concurrency. And once it reaches the target concurrency, it will hold the load for 2 minutes, right? So basically it will, it will target this endpoint with GET requests for 2 minutes. Now, for seeing the questions, there's not just GET requests that we can use. We can definitely use POST and DELETE requests. You can also specify your authentication tokens in the headers. That's obviously a very important feature because many of the endpoints are secured. So there we go. And of course, for POST requests or PUT requests, you can specify the body. For sake of simplicity, not doing any of that now. And so all that, I am going to kick off our test and see what happens. So now we are in the running test mode. You see that it shows the test is running, right? And what we would like to see is what happens behind the scenes under the hood, right? So let's see if we can go into the state machines. Remember, there was part of the Lambda functionality, the state machine, which is coordinating overall orchestration, right, of the task. So here we have one in flight, and as you can see, we can we can see which step it's running right now. So this is visual presentation that you can also look at that as table. Again, this is not required to run the test. I'm just showing you under the hood if you need to debug the system or would like to understand deeper how this works. This is where the orchestration happens. And we can see, events that are associated with this step function execution. Now, if we look at the ECS console, remember ECS is the engine that runs our tests. Elastic Container Service. So we'll see that we have 2 running tasks, right? And for this task is, basically it's similar to a pod, right? It's something that is defined. It contains an image. Just very quickly to show you, obviously I'm going to go for each and every field here, but important pointer is using the image that's contained in the public ECR registry, so it's pre-built. And also there are parameters that request certain compatibilities, right? So it can run on EC2 and Fargate, and it should consume these CPU and memory resources, right? So this is task definition that it's currently running. And we can see what containers correspond to that. We can go back to running tasks. And if we choose to, again, for debugging purposes, we can look at the logs, right? So we can see detailed logs that containers tend to produce, right? So we can see the bucket where it will write the results. There see certain internal information, and this information will be also available after test completion, but we can monitor it in this console. And if we choose to do that, we can also jump into our log event management system, CloudWatch. It will automatically direct you to the group that's corresponding to this Fargate task, and you can see the same information nicely grouped into these categories, and you can further, query it and review it, etc. Now let's see how our test is progressing. So I think it is complete, isn't it? No, running, still running, okay. Quick question, is it making sense so far? Are people following, or am I confusing people with too much information? Just kind of quick feedback.
No questions so far in the chat, Daniel. And if anyone has any question, please feel free to put it in the chat, and we can make a few pauses for Daniel to answer.
Yeah,
Yep,
I have one quick question. Is it possible to add some additional steps to load testing, or it's just for endpoint? For example, like a couple of steps for UI load testing?
So if I understand your question correctly, and I'll also let Basim, who's SDE, actually working on the code, add color to that. I think this can be done using the JMeter, right? JMeter is popular load testing tool, and I'm not sure you're working with it or not, but you can have your JMeter JMX script that contains, endpoint and various operations you want to perform on that endpoint already scripted. And that's what I'm going to show you next. And you can you can run JMeter script for the same engine, if you will, that we're running the simple endpoint test.
Okay.
Basim, would you like to add something?
No, I think the only thing to confirm what is available within DLT is to check what is the supported protocols for JMeter, and those should be covered by DLT, because you can write your own JMeter script testing either an HTTP endpoint or having a GDB connection, or a web service SOAP tests, or I don't know, FTP protocol. So all these protocols supported by JMeter should be supported by DLT as well.
Mm-hmm.
Makes sense. Thank you.
Sure. So let's go back to our test in progress. Let's see how we're doing. It's still running. So how we're doing on time? Let me see. Because I
Technically,
said
technically we have another hour, but if you have a test that maybe is completed from your previous demos, we can go from there.
Sure, we can do that. Yep. Yep. So we look at on the hood, we see what's happening. We see that the tasks are running containers that simulate our free tasks with 5 users each. We're holding it for 2 minutes. So hopefully it will be over soon. But if not, we can, there we go. Okay, so it just completed. All right, so we have completed that, and we have this sort of statistics, right, about our requests, right? We have it in the form of a table. We have the average parameter, average metrics. Average response time was about 1.4 seconds. Latency, about 110 milliseconds. Connection time and bandwidth, right? We have a total count of requests, which consists of success and error, right? And this is average request per second. And here we have our distribution of percentile. So, 100% was at around, 4.65 seconds. And, these are 50% percentile, 90% percentile, 95% percentile, sort of like the distribution of response time across all the requests, right? Here we have a graph representation of that. We see that, again, sort of distribution of, virtual user successes and failures per average response time, with the average seconds per each and also total, right? It's kind of all combined data in the graph form. And if we want to review detailed results for debugging, if something fails, like for example, why errors have been detected, we can jump to the bucket, right, to the resource bucket that stores it, and we can download a log file that was generated. Let's see if we can do it, and probably will have to switch the sharing window. Okay. Okay, so this is the log file. I just open it in the regular text editor. So it starts with all this, torus, output, etc. You don't have to worry about that part. It's mostly debugging information. You can see that JMeter is also, torus is built on Apache JMeter. What you would be interested on is these tables that are generated at the end, towards the bottom of this log file, right? So again, you remember that was a table on the UI that was showing the percentile. So here's that table in the text format, right, in your debug file, right? Also, there were a few errors, right? And this is, again, pretty important for me as a developer because I'd like to understand what exactly happened, right? And I see that, the socket was closed, which is not unexpected because this is just one container running on EKS, and we're trying to bombard it with pretty high load, sort of like simulating a mini DDoS attack. And, in some cases, the socket just get closed and we get this error, right? So, in this particular situation, it's making sense. And you as user can always obtain these files from the bucket, S3 bucket, and download it and examine it. And let's go back to our console. Okay. Now, are there any questions, so far? Because next thing I was going to talk about is JMeter-based testing. Basically show you quickly how I created this test and how to run it. And also mention that we can run this test in clusters, ECS clusters deployed in different regions. Are there any questions so far?
No question in the chat, Daniel.
Okay. All right. So far we were running our test in the same region where we have our solution deployed. That is Ohio, US East 2, right? Now, if we want to expand, right? So I started with only US East 2 available. If you want to expand it, we copy URL of this template. We navigate to the region where we want this to be deployed, right? That is, in my case, US West 2. Sorry, I'm jumping across.
By the way, one comment here. One of the reasons why you would like to extend DLT to other regions is, for example, if you want to do a big simulation. As you guys probably know, ECS, there are some quotas that you might not be able to run more than X number of ECS tasks in any particular region. So for example, I just a few seconds ago, I just posted a press release of a company I just met with a couple of weeks ago when I was in Japan. This is the largest stock trading company in Japan. When they migrated, this particular platform that does all the stock trading, when they move it to AWS, they actually use DLT to do all the performance testing and the workload simulation to make sure that environment was resilient. In that particular case, if you think about it, being the largest stock trading company in Japan with millions of users, accessing the environment, that's where you want to create this DLT testing in multiple regions so you can, make sure that you can create enough, right, ECS tasks or containers running in those geos. You can, of course, request a quota increase, but based on your workload, you might need, to expand to more than one region, or if you have enough quota in that particular region, you should be okay doing that particular test. It's completely up to you, but DLT gives you the flexibility that if you have a quota and you hit that quota, you can extend DLT to other regions and consolidate all those user simulation from multiple regions into one single endpoint for the testing.
Mm-hmm. Yeah, thanks, Liz. That essentially gives your more engine, right, to use the power of. So yeah, that was definitely an important point. So again, what I did, I just followed the instructions on the console. I downloaded basic copy pasted the URL, ran it here, and it created another instance of the cluster, ECS cluster, ECS, with the corresponding subnets, task definition, security group, everything that needs to run the tasks, right? So if we go back to to this test, which is I call multi-region, right? So notice that now I have two regions available, and I selected US West 2. That means I will run my task on the cluster deployed in that region. And as Louis said, and I pointed before, here's your cheat sheet, right? It basically shows how many total you have available, right? If you really run large scale and you start eating into your quota, these numbers can decrease, and that again helps you to plan your test load better. Okay, so I'm also running a very simple get test, against my GitHub username. It's just the point is I'm running it in the different region from the central control plane in the US S2. So same thing, it's going to kick off the tasks. We're going to jump into the console. So we have to go to the console in this region, to the cluster in that region rather, right? Okay, see, we have our tests that are about to be scheduled. Same thing, we can look at the task definition, which is this one. Remember that we also had it in the main region, and it's pretty much identical. So we run exactly the same task, exactly the same, declaration, definition, just on the engine ECS, which is in different region. So there we are. Our tasks are pending. hopefully will be running soon. It takes a little while to provision because it's on demand. There's no sort of fixed infrastructure because it runs on Fargate, which is our serverless dynamically provisioned infrastructure. That's why it takes a little while to kick off, to get this task to running state. No logs yet because they're still coming up. Okay, so finally they are running, you can see. And as with the case with the task running on the main cluster, we can see the same detail output. We can also see it in CloudWatch, where it's more nicely grouped, right? So we can see, internally generated test ID, type of test, so all these details of test payload we're seeing in the CloudWatch. Okay, back to our main console. Let's see if we get any updates for our data. One thing we haven't seen is, we haven't specified the live data, so that's why we're not seeing it. And at any point, we can still click on these links to our execution, which is at the bottom of the page. And this one, right? And we can view details. It opens the details page. It gives us the results to date. And we can also go to the bucket that contains them and also download the logs as we did before. So we can download it and examine the log file, which I'm not going to do right now because we'll have to switch the window again. For interest of time, let me also kick off the JMeter test that will run in the main region. So nothing prevents us from executing multiple tests at the same time. So once again, I can choose any region to run it. So let me choose the US East 2. My test is pre-programmed, if you will, in a JMX file. It also basically hits the tutorialpoint.com index HTML, nothing super complicated. And I just want to show that how you upload your JMX or a zip file, right? So this is your customization that somebody was asking before.
Yeah, sorry, one quick question. Total count is total TPS, which you want to hold for 2 minutes? What is? So how to generate total transaction per second for this load test?
So it comes from the number of tasks, right? And concurrency. So 5 tasks with 2 users, or let's say 3 users, it's going to be total 15 requests, right? Within each request, we, depending on your execution file, you can have additional number of threads, I think, that are executed, right? Because it's based on Java. So
keep in mind that what you're setting up in this particular screen is 2 different things. You are setting up the workload, like how many users you are simulating, and from the JMeter script, what you are specifying is that what's the actual action that particular virtual user it's supposed to execute, right? So it's a
Correct.
combination of both, right? One is like, hey, I want to simulate, I want to simulate, 100,000 users, and for me to get to 100,000 users, I need this many containers, and I need this many concurrent users per container. And from JMeter, what you can do is that, okay, I want each of those, 500,000 users to simulate this particular scenario, which is go to the login page, enter a user, enter a password, then do this or do that, or call this API or gRPC call, because at the very end, the actual execution, the actual like test is going to be defined by what you are coming through the JMeter script today, but eventually K6 and Gatling scripts will also be supported.
Mhm.
Okay. Yeah.
Right. So
Thank you.
basically, all this additional testing logic is encompassed in this JMeter script, which I just showed you how I created, and I'm running the same script now for the DLT solution, right? So yeah, thanks, Luis, for the clarification. So let's see how we're doing with our tests.
So Daniel, is 7:10? Again, I want to be respectful of everybody's time.
Sure.
I don't know how much longer you were planning on going, but I want to make sure that any Q&A, any comment, any feedback, and remember, as I mentioned before, if you start using this solution and you have feedback, you want to like, hey, Luis, I like the solution, or I don't like the solution, please reach out to us, because again, one of the things we can do is define and control the roadmap and future of how this solution works and behave, and we can make changes, basically working backward from the customer.
Yep. I think we covered the main part. I mean, we can obviously wait a few minutes and see the completion of this test. We will see some summary results, similar to what we see now, right? In this case, it errors out a lot, so we can try to understand why. And this is normal, right? Because after all, we're running our load test to see what the problems in our system. But fundamentally, this is the mechanism, right? So you define your test scenario using the UI, right? You can customize it to your heart's content. You can use, various HTTP request method, get, put, right? You can, pass your headers for authentication. You can put your body payload for the HTML form, and you can definitely run more tasks with larger concurrency to really create a load on your endpoint. And you can, by the way, I haven't mentioned one thing, but you can run on schedule, right? So you can use a certain date, for example, tomorrow, and time you can specify, right? So you can do that, or you can even schedule it as a batch execution, let's say weekly. Let's say, you're working with a developer team, they put a weekly build, and you want to test it, and so that would be an option for you to schedule on a weekly basis, right? So I think what we're hopefully we learned today is this is a very flexible tool that lets you create and run and analyze results of load testing very efficiently, and you can work with your engineers to help them identify the root causes of these errors and address them. And this is what we offer our users and customers to make their software development test process more efficient. Yep.
Perfect. Thank you, Daniel. So let me take the screen for one more second here. And guys, what I would like to do is, number one, invite everybody to come to our AWS Solutions Library. You will find distributed load testing, but you will also find a bunch of other solutions and guidance that might help with many of the projects and initiative you are working on. And this is our contact information. That's me. I'm based out of Miami, Daniel in California, and Basim in Ottawa, where I was actually with Basim yesterday and running a couple of meetings. So we will be happy to hear back from you if you have any question, any needs. And now, if you have any question, comments, feedback, insights, we can stay here for a few more minutes.
I just wanted to say thank you all very much. This is actually very exciting. I was having a, although you probably hear my children behind me, but I was having a very heated discussion this afternoon with my team about trying to find these performance degradations before we ever get to production. And although our solution is not like a web application, I think some of this could actually be brought back to our team. So I was not aware of this solution until now. So thank you.
And this is exactly why we're starting with this particular one, because even if it is not a web application, I mean, JMeter support multiple scripts. And remember, JMeter is kind of the framework we're using, but the solution itself, again, it's what kind of bring all those framework and all that testing to life. And as I mentioned in my chat, one of the biggest or hardest pieces of doing performance testing is how do I run this simulation? How do I run, 100,000 users? How can I do that very, very cheap? And this is exactly how DLT does it, through ECS and Fargate, because it's serverless compute. And, if you look at the cost details, it's very, very cheap to run performance testing.
And one thing I would add to what Luis just said, of course, we're all excited about generative AI. I'm sure that in your organizations, or I suspect that's discussed one way or another. And so generative AI, models, they also have endpoints, right? They have to be exposed to the endpoints. So, our chatbots and other applications should access them. And of course, you want to test performance of your Gen AI model, right? To see how it will scale if it's rolled out to production. So, here we have pretty much ready solution, because from this testing tool perspective, Gen AI model is nothing else than just another application with an endpoint. So that's something that also can be considered, because it's basically agnostic to what kind of application it's testing. It just needs the endpoint or whatever JMeter supports, and it can give you very helpful results.
Yeah, it's a great solution. I was also looking, it would also be useful for like before you migrate to the cloud as well, for on-premise to test the solution on your applications before you migrate.
Yeah,
Yes,
you can test your local. Yeah, you can test your local URLs.
Distributed load testing runs on AWS, but the application you want to run the performance test against could be running anywhere, on-prem, on AWS, on a different cloud. It doesn't really matter, right? The only thing that you need on AWS is DLT, right? The press release I put on the chat a few minutes ago is actually a company, as I said, that migrated from on-prem to AWS, and they use DLT through the entire life cycle of not only the application development, but the migration as well to cloud. So you are more than welcome to use it. And if you guys have any questions, just reach out, and we will be more than happy to engage on a one-on-one and give you all the support you need. So there was a question about, like, if you are a student or you don't have access to a corporate environment where you can learn more. Look, there's plenty of material out there. I'm more than happy to connect personally with anyone, and like introduce you to a couple of places within AWS where you can learn more about these. But I do believe that AWS has a program for students, and I just need to do some research and connect you to that place. But if not, Google search is your friend. There is a lot of material about this. Wrong microphone, John.
So sorry about that.
There you go.
So AWS has AWS Educate, which is something that is available for your professors. If you are a student in a university, and you have a professor that you're kind of close to, you can work with them. Everybody would get a $50 credit within the class. It is actually pretty easy to set up an AWS Educate account. If your professor is not familiar with it, just connect them with me on LinkedIn, and I am more than happy to help them with that. That is at least something that will keep you safe from having to set up your own AWS account, because I will be honest that it's a little scary. But AWS is good. I have made mistakes, and I will let you know they have refunded me on my mistakes that I have made. And they were not cheap mistakes. So they are good to help out, but I mean, to save you that pain, if you are in a university or something like that, there are options to be set up with a professor or a teacher, and that can help.
Yeah, and thank you for that, Joan. And again, also please connect with us on LinkedIn, right? It's all about networking. Once again, that's why I love using groups, because it's the networking, it's the value you get out of this. I knew that there was going to be students in this call, so if there is any way we can help those students be successful in their upcoming professional life, I would love to do that as well.
Yeah, for example, if you're building some website, you would like to load test it, there we go, right? It's a free tool. Just yeah, and just like Luis said, I mean, we like nothing more than connecting with our users, who may or may not become our customers. Would like to hear from you. We have one of our principles is customer obsession, so we definitely enjoy meetings like that, conversations directly. If you're thinking of using this tool somehow, or you're, some other solution you find on our solution portal, we're definitely very happy to engage and discuss it further.
Awesome. So guys, if no more questions or comments, I'm going through the chat. Can you add me on LinkedIn? So yeah, I can add everybody on LinkedIn, or you can add me. My last name is kind of unique, so I will be probably the only one with that last name you will find. But happy to be here, Joan. I will follow up with Jeff to see if we have other solutions in our portfolio. Maybe we just started with this one. We have solutions for networking. We have solutions for Gen AI. So maybe I'm gonna let you kind of test the water to see what would be another solution we can bring to the user group at a future date. This is just the very first, hopefully, of many sessions we can do with you and your user groups. And I'm also working with other user groups as well. So if there is any opportunity for cross-pollination, we can do that as well.
Perfect. Thank you so much. And everybody, thank you so much for coming. And if you have anything, feedback or anything that you want, it's been shared on LinkedIn. You can find me on LinkedIn, and I'm more than happy to connect with every single one of you. And if there's something that you want to learn about, let me know so that we can continue these sessions.
Awesome. Perfect. Thank you, everybody. Have a wonderful night, and looking forward to talk soon.
Thank you all.
Thank you. Cheers.